Hello guys, welcome to a new video. Today we're going to be talking about SN1 reactions. We're going to be talking about some of the characteristics that needs to happen, and we're going to be talking about a problem, an example problem. And we're going to have a video about SN2 reactions as well, coming shortly. So SN1 reactions, they need a carbon cation. So in my videos previously, I believe I had talked about carbon cations before, but well, they don't need a carbon cation. A carbon cation will happen, you know? Carbon cation, something like that, something as follow, it doesn't, it's missing one bond. So they need a protic solvent. Protic solvents are stuff that have hydrogen bonds. Hydrogen bonds, not because it has hydrogen, it means it has hydrogen bond. Not because it has hydrogen, it means it's a hydrogen bond. So, not only F's. Bonds has to have oxygen, nitrogen, or fluorine. Only failures, right? Because fluorine does not work really well as a protic solvent, right? It's depending textbooks, like HF, technically protic, but fluorine does not really work as a protic solvent. Why not? I hope you remember the fluorine is extremely electronegative element. What does electronegativity means? Do you know? Eileen, what's electronegativity? How much what? Yes. Electronegativity is something, how much something want electrons. Oh, I really want an A on my organic chemistry class, but I'm more likely to make a B right now. But let's not focus on that. Electronegativity is how much something want electrons. So fluorine really wants to make this bond with hydrogen, right? While nitrogen and oxygen, they want to make the bond with hydrogen, but they're more like, like, I could eat some chips right now, but do I want them that much? So even though these are fluorine are part of hydrogen bonds, they are really not protic solvents, right? So some examples of protic solvents are hydrogens attached to nitrogens or oxygens. Some example of protic solvents are water, alcohols, and no ethanol, no, talking about OH. Acetic acid, we all know acetic acid, it looks kind of silly. It's like R, you can see, R, after that, there's a little C, after that, double bond OH. Acetic acid, that's a protic word, and ammonia. So those are some examples of protic solvents, right? So we have our living group leave. Hey, I'm a living group. I will get into this part later. We have that, and after that, we have our nucleophile attach. Hey, I'm a nucleophile. I will get into that part later. That was 2 steps, guys. 2 steps. Living group leaves, nucleophile attacks. We have a carbo-cation intermediate. So that's a 2-step reaction. The rate depending on the substrate. Okay, so let's go. So what's the substrate? The substrate is substrate. Oh, tabi was ugly. Substrate. So that's what a substrate is. It's like the molecule that carries the living group. What's a living group? I'm sorry for leaving that at the end. That wasn't smart of me. Okay. Like, so yeah, we'll have an idea, right? So the substrate is the thing, the molecule that carries the living group, right? And the nucleophile leaves. So what's a nucleophile, Jesus? I already speak about this I already speak about this. We're not going too in depth into this subject because I have already made a little video about these. Well, no, it was about like endogenic and exogenic reaction, but still, like no rates. And people love that video, so please go watch it. It's the only video where outside people have, like, meaning outside people, meaning like people know in my circle of life have commented. So I love that video. So, anyways, enough about me. So in the step 1, right? Bromine leaves. Slowest step, right? Takes time for bromine to be like, hey guys, we're not friends anymore. And this is the rate determinant step because it's the lowest, right? So, ooh, you see, like, okay, that was cringe, but like, you understand the thing, like, this is more important how long I go to like do this than like the last movement. That's why it determines the rate, the determinant step, because the fast step doesn't really matter because it's like seconds, you know, like it doesn't change that much the rate of the reaction, if you can understand. So second step, the nucleophile comes to the carbocation. Oi! To the carbocation. Carbocations are positive, not negative, right? So that's what happens in the second step. Oh, what's a nucleophile, Jesus? Oh my bad, guys. I thought I already explained to you, but I just remember I haven't. Nucleophile, I remember bases. Nucleophile bases. That's how I remember it. Not every nucleophile is a base, but that's like vice versa, you know, like but let's generalize it right now like that. And I think about like basic people, they're in the nucleus. So nucleophile bases basically in the nucleus. So geometry. What do you mean geometry? Like, it's a easy way for me to say this. So this SN1, yeah, this wants to leave. There's too many people around him wants to leave. SN2, whenever you have two things attacking, there is no space for this attack to come. So this cannot happen. So that's like geometry, right? Remember, like tertiary, secondary, primary. So tertiary carbons are the most likely to have a SN1 reaction. Racemization. That's, we're gonna talk about that after this translation. Oh, racemization. Racemization. So this happens in SN1. All of this stuff is for SN1. Let's remember. SN2, different story. Next video. Okay, this happens in SN1, racemization. There has to be a chiral center. Jesus, what's a chiral center? I believe I might have mentioned this in an earlier video. I'm pretty sure I have. It's called R or S configuration, maybe. Maybe not. I don't know. So chiral center, sp3 hybridized carbon. What's a sp3 hybridized? Watch my other videos. Okay, carbon. No, never mind. I'm sorry, guys. sp3 hybridized carbon is a carbon that has 4 bonds. Yeah. So 4 bonds, sigma, single. So sp3 hybridized carbon, so chiral, and they have 4 different groups, like blah blah blah, blue blue blue, hydrogen, hydroxide, no, alcohol, hydroxide. So there was hydronium and hydroxide. Hydronium. Okay. I want to sit down, guys. Hydroxide, hydronium, question mark. I'm 100% sure If not, like there will be like a big meme happening right now. Was there a big meme happening right now? No, then I'm qualified to be making these videos. Wink, wink. Not, guys, I'm not. Okay. Okay. I hope you're having fun though. I hope like this is a little break from the other videos that you've probably been watching. Where it's a little bit like these people know a lot and they're like frustrating watching them because they'll break the stuff to the easiest, to the like the simple stuff. I hope that's the difference I'm making and that I'm easier to watch because I believe I'm funny. People think otherwise. So anyways, this has to be planar. Planar. What does it mean? This? No. No wedges, no dashes. Planar. So that's reciprocation. Oh, did I explain? No. So reciprocation means that like the product can attack in the back or in the front. So if we have like a product attacking in the back or in the front, so I think I have bromine there. So let's say like you gotta replace substitution nucleophile 1. Okay, nucleophile substitution 1. So like it gets substituted by alcohol. Oh wow. It got substituted by an alcohol. Oh wow. This happens 50 on SN1. It needs to be planar, it needs to meet those conditions, and that's what racemization is. Racemization. Racemization. Enough tomfoolery. So, SN1 characteristics. They don't need to be good nucleophiles. What did we say about nucleophiles? Okay, nucleophiles are bases. Okay, so they don't need to be good nucleophiles. Okay, this is what it makes. Okay, bro. Nucleophiles are bases. So these anions of halogens, they're okay nucleophiles, so they cannot break the nucleophile. But it's like they don't have to be. They don't have to be good nucleophiles. Like water, like we remember from our basic chemistry classes, water cannot be as an acid or a base, so it's not the greatest nucleophile, right? So we have alcohols, ethanol, and we have more alcohol. So they don't have to be good nucleophiles. What's another example of AS? What's another characteristic of SN1? Have great living groups. BR loves to live. Greatness. Great living groups. Loves it. It loves it. So let's go with an example. Okay, and before we have another transition right here, we have to talk about something. I'm making a video about SN2 reaction, and maybe that's it for the organic chemistry videos 1. So if you are here watching the video until right now, thank you so much for your support. You are goated. If you want me to make more organic chemistry videos, I can make any video until Wednesday. Any video, anything at all. And after that, I will be studying this summer for organic chemistry too. So if you need me to make a video for organic chemistry too during the summer, I'll make them. I'll be studying for them. I'm gonna change content a little bit. I'm gonna like recording some military stuff, but let's go and watch the example. Okay? Thank you, y'all got it. So leave in the comments. Like really, leave in the comments. A specific reaction was on my test. And not gonna lie, because I made no video about it because I've been busy with other subjects and stuff. I got this question totally wrong. So I'm gonna try to solve it right now with you guys. And after that, I must check if my answer is correct. We're gonna check the correct answer. And after that, we're gonna see what I did on the test and why my answer was incorrect. So first thing we do, we identify that this is a SN1 reaction. How do I identify? This is a protic solvent. I got that part right, at least in the test. So protic solvent, a little tip that my teacher gave us, that it's not all the time, but so far we have seen it. Abbreviation, well, you get it. Abbreviations, they're equal to aprotic, right? So D, bro, D. Okay. D, why did okay, I'm so sorry, guys. Okay, D, M, D, DMF, DMF, DMF is an aprotic, and it's an abbreviation of something else, you know? So aprotic abbreviation. So whenever you have the actual like chemical formula, it's usually protic. Not every single scenario, but this is usually what happens. So CH3O. So we have an alcohol. So monkey eats purple banana. So monkey, methanol. Okay, so we have a methane, but it has an alcohol, so it's methanol. Enough. Okay, so we have a protic solvent. Remember protic, aprotic. So protic is SN1, aprotic SN2. So protic, right? So I know it's gonna be a SN1 reaction. I know that the leaving group's gonna leave. It's gonna be like, bye bye, guys. Right? So, boom, 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 sahur. So, and after that, the carbons. You know Markovnikov rule? How I talk about Markovnikov rule? I don't think I have the Markovnikov rule. Markovnikov rule states that the cation is going to be the most substituted carbon. They're equally as substituted. They're equally as substituted. I'll put it here. So after that, I have my solvent. The mistake I made on the test that was like, oh, OH is a nucleophile. So I'm just gonna break this, and this is a nucleophile, so it should have a negative charge. Really, guys? Really? I was like, oh, okay, we'll go over my mistakes later. So this actually breaks like this. If you ever see a cut in the YouTube video like that, and I was talking, and you see a cut, it's because I probably did something wrong. And this YouTube video is the first time I do it. But okay, can you tell me what's wrong here? I can tell you what's wrong here. I was a little bit egocentrical, and I didn't even look at the products. I was like, oh, I can do the reaction myself, and I didn't even look at the products. Where was the carbocation form? Right here. That's where it was formed. That's where it was formed. Why? Why did I put the carbocation here? I'm dumb. Well, I'm not dumb. I should never talk about yourself, guys, because I'm silly. So in my test, I had to in the homework you had to describe the mechanism, right? So, but in the test, I had to. So the mechanism after that this breaks is positive, right? And you have that positive, and after that you have this one being left for negativity, right? So you have positive, negative, right? And after that, this one is gonna. Well, this one doesn't work like this. It's just an example, so yeah, understand the charges. I understand that can be deceptive, but like it doesn't break like that, right? It doesn't really matter. So this one's positive, this one's negative. So the negative one is gonna come and attach here. So it's gonna attach here. So it's gonna do a little. It attaches, CH3. So right, so that's what we have over here. That's what we have over here. So now let's look at what I did. In my test, the things were a little bit different. You had to guess, right? Oh, why did I delete everything? But let's see the mistake I made in my test. In my test, I was like, oh, this is a nucleophile. Definitely, it's gonna break. It's gonna break, right? It's positive. positive, and this is positive. But actually, in my test, I said this was negative because I was silly, because I was trying to rush. Let me connect this. Well, so I was trying to rush everything, so I forgot it was a carbocation, and after that, you get nervous during test, so I was like, oh, this is a carbon anion. So I was like, the positive will go here. The only way we can have a positive charge, right? So I was like, CH3. So first mistake, SN1 always forms carbocations. They always do. They always form carbocations. How can it be a carbon anion if it's missing a hydrogen? Why did I put carbon anion? I don't know. Why would this break like this? Why will it break like that? That's not logical. Whenever you know that SN1 is gonna form a carbon cation, you know this wants to form an anion and a cation. So that's the only way that we can do it, negative products. So if this breaks down, this is the only way. So oxygen is missing, and this connects over here. So if you watch to the end of the video, you are goated. Woo! Okay, thank you for everybody that subscribes to me. Please subscribe. If I get to 500 subscribers, I can make some monies of this. I need to start making some monies of this. I need to start making some money of this. So that would be great. Leave in the comments any video you want me to make. I'll make it. I'll make it, guys. It doesn't even have to be this. You can be like, Jesus, how do I fix a car? Or not. I'll grill it up. We'll fix it. So thank you so much. Thank you for watching the video. Yeah, a big high five. Oh, a big like. And see ya.